Good evening, dear ladies, gentlemen, and those who still think that everything here is computer graphics. In this video you will see 4 different ways of making the most iconic Iron Man armor or other favorite costume if you have one, using a conventional 3D printer, but not only made of ordinary plastic, but also completely made of metal. Alex Lab is here with you, and we continue to make a real Iron Man suit. Let's go! Okay, situation. What do we have right now? I assembled some parts of Iron Man suit's power system that runs on hydrogen. Now we have several hydrogen reactors of different power which convert water to fuel gas and powered by lithium-ion batteries. Also we have a chemical reactor based on aluminum oxidation which works without electricity consumption and produces pure hydrogen in large quantities. Both fuel sources are suitable for Iron Man repulsor, pulse jet engine and some funny stuff. In addition to eco-friendly fuel with energy density slightly lower than the enriched uranium, reactors give a whole bunch of free overpressure, which I adapted to power the artificial pneumatic muscles. Hydrogen muscles works as drivers of the exosuit. They catch neurosignals from my own biological muscles using EMS sensors and enforce the suit. We have a power system, we have an exosuit, and we have the muscles. In short, there is a cool multi-layer gadget which is time to start packing into the authentic Iron Man metal armor. But I know you guys started making your own versions of the suits too, and I understand that not everyone has a full-fledged workshop with an argon welding machine in the basement. Therefore, today I will show you 4 different technologies of making the armor, so you could choose which one you can make yourself to build your own costumes. So, we need to pack our biological body and half of our hydrogen toys inside the Iron Man armor. And of course I want to make the armor not just look like in a movie, but exactly like in a movie. While I was making a metal mask, I already realized that if I make a 3D model, preform, templates and patterns manually by myself, then I will be able to test a full suit closer to retirement. So, we need more advanced technologies that will speed up building of the suit. Good news, we guys in the trend now. Iron Man movies created the whole universe of geek communities on the internet. You can easily find enough ready-made 3D models of the suit. The website that I love the most is do3d.com, not only because these guys are crazy geeks who are focused on the Marvel and DC universes, but because here you will find all the Iron Man suits that have appeared in the movies from the first part to the Avengers Endgame. But so far, these only virtual 3D models. What is the main advantage of a 3D printer? It creates any 3D part with an accuracy of tenth of millimeter entirely or in parts, and it does it himself, while you're busy with more qualified work. The main thing that you need is a well-done and exposed 3D model. You keep asking what to study and what to spend your summer on. So start modeling. If you are not going to model the part yourself and only print ready-made 3D models, I highly recommend that you study a couple of fully-fledged 3D programs. For example, a completely free Blender for models such as suits, bodies, faces and body parts, and one precise CAD editor such as AutoCAD for building precise parts, details of mechanism according to drawings and sketches. Because when you finally got a printer and a 3D model, the first 2 questions will be how to adjust the element of the suit to your dimensions and how to split a large part into several parts. These tasks require minimal 3D modeling skills. Take a photo of yourself from the front and side Take measurements of your body with a measuring tape and take several days to the topic of mesh objects 3D modeling. This way you can make a simplified virtual copy of yourself and save tons of plastic in the future because you will print parts of the required size. I'm a lucky guy because I already have my virtual twin with exact dimensions who lives in super gloomy and dark computer game series. I helped to develop several locations in this game so they look more realistic, and developer added my character to the game in gratitude, or rather my very dark alter ego Mr. Brukan, which will appear in the next update of the game in Steam. In short, I just pulled Virtual Alex out of a computer game, put this poor guy in a slicer and scaled all dimensions of the costume exactly according to my forms, plus a stock for hydrogen equipment. When the scale is selected properly, set the print settings. Here are my preferred settings for details such as suit parts. Layer height 0.2, wall thickness in 3 layers, that means 1.2 mm if the nozzle is 0.4 mm. Set the percentage of filling in the range of 15 to 30%, depends on whether you plan to fight on a Comic-Con in the suit. Print speed is 50 mm per second or less to avoid unnecessary defects. Start the printer and do something useful. Using a soldering iron, process the end parts and remove a typical comb after a 3D printer. Also using a soldering iron and glue, connect the parts together. After connecting the elements, align the part from the proprietary 3D printer relief. To do this, use a sandpaper with a grain size of 80 to 180. You can sander by hand, but if you still want to wear a suit until retirement, it's better to buy an eccentric sanding machine. This is roof sanding, so that's okay if you sand up to 0.2 mm across the entire surface, that is half the thickness of one layer, to smooth the surface. After processing large areas, work on small parts with a multifunctional machine and manually. Degrade the entire part with a solvent and fill in deep defects with one component filler for plastic. The more common 2-component filler is not particularly suitable. Maybe I'm a dummy or 35 degrees indoors is too hot for this solvent, but the 2-component filler still cures while I mix it. Remove excess filler parts and go over the entire area with 500 grit paper. Then degrease and prime the part with a spray primer. I just now learned the difference between filler and primer. It turns out that there are two different things. The filler fills in deep defects and holes. The primer smoothes out small imperfections in relief and ensures good adhesion of the detail and paint. when the spray primer dries up, proceed to finishing. I do it by hand using 1000 grit paper, then 2000 grit, and then a felt pad with a plastic polishing paste. So we get a perfectly smooth surface with good adhesion and proceeded to painting. After painting, add the secret component graphite powder. That is the component that gives specific metallic hue, shine and reflection. Apply the powder evenly and neatly with a soft makeup brush and then furiously rub it with a cotton pad. If you're a really crazy person about small details, then work it out after the powdering. But it's better to do it after the powder and do not use any masking tape as I did. It will not let the powder lie flat, or will pick it off in pieces. Inspect your work in different lighting conditions, and although after all this indoor chemistry I already want to go sniffing the real slippers, cover the product with a couple of layers of varnish. So this is the first and easiest way to manufacture the suit. A great option for cosplayers and aspiring engineers. It will help you to significantly upgrade your modeling and manufacturing skills. The parts are made by the printer while you sleep, and all other work can be done at home, on your knees. You can prime and paint it on the backyard and as a result get exact parts like in a movie. So remember everything we have learned yet and move on. Okay, what is the main problem of a suit printed on a 3D printer? That's right, the strength. Suit parts, especially large parts, break quickly if you use it beyond simple posing. In 90% of cases, unless it accidentally run into the construction fitting, parts break straight between the layers. Therefore, now I propose to move on to the technologies of composite materials. Before enforcing the parts of the suit, I wondered how much stronger the parts will become if they're reinforced with the carbon. I tested the PLA parts and the same PLA parts reinforced with the carbon and epoxy resin. With good gluing, parts that could only support 1.5 kg could withstand 4.5 kg of fracture load. If there would be a vacuum bag for gluing under vacuum, it would be even stronger, but not all at once. The maximum fracture strength is achieved if carbon fiber starts to break, not bend. Greater strength can be achieved by gluing the part on both sides. But even 1 or 2 layers of carbon on the inside of the part gives a huge increase in strength. Set the print settings the same as in the previous step and start gluing. In addition to carbon, we can also use structural fiberglass. It is cheaper and more affordable than carbon. Also, we can try Kevlar, which is more stronger than fiberglass and carbon, but according to the prices, in order to reinforce the entire suit with Kevlar, you must mostly likely have to sell one kidney. Carbon or fiberglass reinforcement parts is the second method of making armor. It is suitable for an active cosplay suit, and if you make not one but several layers of composite, then the strength can also be increased for using a suit in airsoft, for custom electric unicycle equipment or motorcycle equipment. Bottom line, a 3D printer gives the desired shape, and composite materials provide significant reinforcement. By the way, do not forget about the full body protection when working with carbon and fiberglass if you want to live a long and happy life and not itch after work for several days. In two previous parts we only imitated metallic covering. Now we will try to cover the detail with a thin layer of a real metal. I apologize in advance that I cannot describe all the nuances of this method, that because I have not yet fully understood this alchemy by myself. The method is called electroplating or electroforming, and judging by the videos on YouTube, it is most often used for applying copper covering to herbarium from leaves. The technology consists in the deposition of metal from the solution and from the donor anode plates on the desired part under electric current. One cool fact: up to this point I have used the electrolysis and the hydrogen reactors that power the suit. Now I will try to use the same process to make the suit itself. The print settings are the same as in the previous steps, but we can play with the percentage of filling to get slightly stronger parts initially. Before immerse the mask in an electroplating bath and start casting, prepare the part. After 3D printing part, everything is the same as before. And sealing, sanding, filling and priming, it is important that the part is sealed and doesn't allow water to pass through. The surface of the mask must participate in electroplating reaction, so it must conduct electricity. To do this, first cover the mask with a couple of layers of graphite varnish. Without waiting for the varnish to dry completely, add our secret ingredient, graphite powder again. The graphite powder, combined with graphite varnish, create a smooth and dense conductive coating. Immerse in the bath with solution of copper sulfate, a drop of sulfuric acid and some other filth, donor copper plates, and immerse the mask itself. Plug the plates to a positive and mask to a negative wire. Supply current and begin long experiments with current density and its effect on coating quality. I spoiled the first few samples because the coating was uneven and loose. But with persistence, one old Soviet book from 80s, and with all the power of Soviet engineering, I was finally able to achieve a relatively even copper plating. It turns out that electrolysis with direct current and pulse current electrolysis gives completely different coating quality. Deposition with a pulse current with a certain duty cycle and current density gives a metal crystal structure of a completely different quality. But even after a week of experiments, this process still looks more like magic than science for me. Just imagine, even 1 degree change in the electrolyte temperature affects the shade of the copper layer. Not a DIY slime making, right? After tightening with copper, washing, neutralizing and building up the copper layer, nickel and chrome plating can also be done. This requires even more difficult to obtain chemistry, constant control of the elevated bath temperature, and most likely knowledge of spells, mandrake juice or unicorn blood. The main thing, the method still works with simple direct current, but you must always understand exactly what you are doing. If we master the art of pulse electrolysis, this will open up the possibility of creating a high-strength metal, wear-resistant coating, resistant to aggressive environments, humidity and shock. I think that the combination of two technologies gives the most amazing results. If a 3D printed part is covered with metal from the outside using electroforming and from the inside reinforced with composite materials. In fact, we get a part of a complex shape which is quite difficult to make from metal, but not inferior to metal in strength and wear resistance. In short, start your first experiments with simple direct current electroplating. Because all the most interesting stuff begins when you just stick 2 pieces of iron into the water and apply a current. Do not forget about your own safety and complete chemical protection when working with this mug. Without reducing the degree and continuing to acidify the myocardium in the 35-degree heat of the summer workshop, we are gradually approaching the top of my current technological skills. This is exactly the way for which I ordinarily bought the 3D printer. How can a 3D printer be used to make the manufacture of complex full metal parts easier? Let's see what are the most difficult tasks when working with metal. Even for experienced welders, there are 3 most time-consuming operations. Make an accurate pattern of parts with complex profiles, give the details exactly those bands that are needed, and as a result, precisely tack welding the parts so as not to confuse the corners and the overall geometry of the product. Let's see how a ready-made 3D part can make our life easier. To do this, remember everything that we have mastered in the previous steps. Use all the skills for 3D modeling, scaling and model splitting so that the printed part is the most suitable size. Now we print our preform with the most rude and brutal settings. Increase the layer height to 0.28, lower the wall thickness to couple lines, raise the percentage of filling to 20%, and the printing speed can also be raised. Here we no longer need smooth walls, we will not process this blank. The main thing is that the part is strong enough for fastening metal parts and tacks to it by welding. Cover the helmet with a cardboard to get the most accurate pattern of parts. If I had thought of this life hack earlier, then I would not make a cardboard model with a protractor, compasses and a ruler for a week. Transfer the pattern to a metal sheet. In the future, I plan to cut out such parts with a laser to save dozens of hours and further increase accuracy. But remember, today we are brutal guys and therefore we cut out the parts with the old-fashioned way, with grinder and small Dremel machine. We now have precise but flat parts that needed to be bent properly. For this case, I use several pipes of different diameters, a small anvil, a table angel and other metal stuff from metal scrap. If some parts are bent too complex in several planes, they can also be cut into several smaller ones and bent individually. We can split parts into any number of elements to achieve high detail. Constantly check the part against the plastic helmet in order to achieve the most accurate bends. In a week we will have all these helmet parts, so quite easily in our own sweat we took 2 difficult steps, cutting and bending. And now we move on to third. Use plastic preforms and paper clips to make fast and precise tacking of parts right on the preform. That is the step that takes all your time without ready-made preform. And with the help of such preform, we actually have a ready-made geometry. Don't worry about the plastic part. Even making the fastest tracks at a current of 50 amperes or less, we will spoil the plastic part in any case. So after the tacks, the part can be cut off with a knife and discarded, it doesn't matter anymore. The main thing is that with the help of the preform, we get a helmet with welding tacks with original geometry. Then it remains only to go gently weld all seams, increase the thickness of the walls in the right places with extra metal, Then work through the small details with the drill and remove all the seams with the grinder and the Dremel machine. I know that you are already at a low start, so let's summarize what we have learned. The simplest thing I advise everyone to start with is the first step. The whole DIY cosplay suit can be made at home on the knee and painted on the backyard. Also, you will learn skills at the same time, which will definitely come in handy in the next projects. To achieve greater strength, up to bulletproof armor or custom motorcycle gear, reinforce the details with carbon fiber or fiberglass or Kevlar. If you want more strength, simply add more layers of composite. If you need your suit to be more resistant to the brutal outside world, immerse yourself in the magical art of electroplating. But it's better to do this no long at home and no on your knee. And the most difficult and costly way is the manufacture of full metal parts using a plastic preform. But finally, you get a real-life Iron Man suit like in a movie. A little rest to do, full dubbing of the video in 2 languages, 80 hours of Final Cut editing, and the video is ready. It may seem that the video ends, but for those who open the description under the video, everything is just beginning. Below you will find a bunch of additional materials on the topics of the video to help you to start your own projects. You will also find the link where you can become a member of the channel and here on Patreon, and to get access to all PDF drawings for step-by-step instructions and manuals and a tutorial of building your own electrolyzers. Watch and re-watch the complete Iron Man Hydrogen Technologies playlist, which is already drawn to a full-length movie. Great thanks to Emily the engineer, Frankly Built, Thomas and Do3D.com and Creality company, and the huge friendly 3D printing community around the world. Thanks to you, the topic of 3D printers are developing so quickly and we are part of this universe. And of course, special thanks to my mentor Colin Firth. You're the one who drove me to this. And of course, thanks to the members of the Alex Lab channel, my dear companions, my dear engineers and superfans and Patreon members. Thanks to your support, I can do what I do. Okay, enough chatting, just read on the paper. I am Iron Man.